All right, ladies and gents, today we're here for another chapter of Agentic Design Patterns. Today we're here for tool use, planning, and multi-agent collaboration. Well, once again, this is going to be a fairly short call. Hopefully, we'll see. Maybe we'll have a ton of questions. So when it comes to tool use, I'm not sure if there is really too much to talk about here. Basically, the idea is that LLMs hallucinate. Well, for a variety of reasons, but one of the reasons is that during SFT, we kind of teach LLMs to follow a certain pattern. For instance, maybe use a citation or provide some numbers. Anyhow, we teach LLMs to follow a specific pattern of the answer. And then later on, when we ask them a question in the real world, or like prompt them to do something, they try to follow the same pattern of the answer, but they don't necessarily have the data to properly fill the gaps in this pattern. For instance, they might hallucinate citations, they might hallucinate numbers, etc., etc. And to combat that, the idea is that we can teach LLMs to actually call external tools like web search, like any kind of APIs, basically any kind of external data providers that can fill the LLM context and then can ground LLMs and that can ground their responses. And the flow is like that when the user requests some information, LLMs are trained to recognize these patterns when they need to insert special function call tokens. So the output system monitors the output of the LLM, and whenever it sees a generation of the tool usage token or the tool usage output, like here it's like some sort of a function call token which embodies the function signature, it actually intercepts the generation from the LLM, goes to the external API, waits for the call to go back, and feeds the results back into the LLM. So, like right here, we have the tool definition. This stuff is embedded into the LLM context. So now LLM has an idea of what tools are available, does the function call, tool executes, results, and we feed it back to LLM to get the final output. And in the book, it's depicted like this. So probably the only thing that we need to highlight here is that it can be a vast variety of tools, starting from some memory services, databases. I don't know why they have storage separate from database. Anyhow, going to web search, using other agents as tools, actually. Accessing charts, maps, basically any kind of data you can think of, maybe a file system. So I guess many of us have heard that well, multiple stories about how user delegated, like ran Claude code with dangerously skip permissions, and then it erased the entire file system. And when it comes to training, I looked it up, and really there is not much to training LLMs to do tool calls. So mostly the pre-training stays the same, so they don't change the labs don't change the pre-training cycle. Mostly it comes to SFT and then various stages of RL. So basically the idea is that we now have either human annotated or synthetically generated patterns of when we need to insert those tool call special tokens that we're later are going to intercept during the generation. So basically we have a few examples, few hundreds, few thousands examples in the SFT step to teach LLM to do tool call pattern, insert tool call tokens with the function signatures. Then we have DPO stage where we push LLM towards good chains and push them away from the bad reasoning chains. And then we can potentially do the unline RL step with the same idea. All right. That was pretty much all when it comes to the tool call. Yeah, another thing, probably last thing, is that we can also teach LLMs to do the tool calls in parallel. But once again, it kind of comes down to the data, so there is nothing really special. It's just a special token tool call. It can be just as well. We can teach LLM to a slightly different tool call signature inside of the tool call token. It can be a JSON, like right here, for instance, we have a JSON function with arguments. Well, it's not even it's JSON, right? It can be functions, array of functions, right? So it's only a matter of data, really. Second chapter for today's call is planning. And really, in that chapter of the book, they barely had any information, so I looked it up a bit. And the idea is that, well, dudes, if you have anything complex, just plan ahead, ask the LM to first plan its execution, and then maybe delegate the pieces of the plans to sub-agents, or even the LLM itself is going to have much easier time if it has a concrete plan with concrete steps. And a blueprint for a good prompt is to design a role and provide specific context to ground the model, because models are basically simulators. So providing a role allows us to extract, kind of push the distribution towards that part of the distribution where the model learned that, like, probably some smart behavior is associated with, I don't know, a scientist or something. So provide a role or provide some context. Provide explicit plan first instructions on what you expect, and provide the constraints of the plan. And here's a good example that you're a senior technical architect. You provide the role. You provide constraints that before writing any code or prose, output a structured plan, and then you provide the blueprint for the plan that you want to see, that there is a goal, there are the assumptions, and there are the steps that you want to take. And at last, probably the most interesting chapter of the book, but still, it didn't have to much concrete information, is multiple agent-to-agent communication patterns. So when we talk about any complex systems, usually these days they're not handled by a single agent, they're handled by multiple agents. And it kind of goes back, I think, to our first chapter when we talked about prompting, and we saw a glimpse of this idea there, that LLMs have much easier times when they have like concrete single responsibility prompts, and that mapped to us in our solid mapping. So with this idea in mind, we can have much better results when we kind of split the tasks between multiple focused, dedicated agents, and the book presents us with several patterns of how we can do this. So one of the patterns is sequential handoff, and this is the one that we kind of discussed in the first lecture on the prompting. So, well, you have multiple agents and you pass the output of one agent into the other, creating basically a chain. And the biggest downside is that, if your agent is accurate with, say, 0.9 ratio on average, then the overall confidence of the entire system is going to go down exponentially. We have parallel processing scheme where we have a problem source and we distribute the same problem, the same idea across multiple agents, and then we somehow combine the results. For instance, I think it's a classical ensemble technique, right? So we kind of have multiple, hopefully uncorrelated classifiers, agents, well, any kind of generators. In our case, they're probably going to be correlated. However, if we prompt them differently, probably we can push the LLM towards different kind of projections of the slices of the distribution. So we can say that they are somewhat uncorrelated, and then therefore they provide somewhat different results, and therefore the variance of the final output goes down, and the but in reality, if we're talking about concrete data, they're going to probably provide different outputs, and when we combine them, we can use another agent to combine them, or maybe if it's some structured output with like verification of something, classification of something, we can even do some kind of voting mechanisms. So, essentially ensembles. Do something in parallel, combine. Lovely. Another scheme presented in the book is debate and consensus scheme. When we, the illustration is kind of messy, but I think it's kind of roughly the same ideas here, that we feed some data to multiple agents in parallel. But then instead of just combining the results, we can feed the outputs of all other agents back to the agents themselves. So for instance, to the agent 1, we can feed the outputs of all of the rest of the ensemble. For the agent 2 gets the output of the agent 1, agent 3, agent 4, and agent 5. And we do multiple iterations until either they converge to the same output roughly, or we have a fixed number of iterations that we can go through. And this is the pattern I personally used multiple times between different LLMs when I needed to debug a hard problem. Like they provided different outputs, especially if we use different LLMs. They provide different outputs, and you kind of force them to debate each other. Another idea is to use hierarchical structures and basically have a coordinator, like a manager agent, that uses other agents kind of like tools. So the manager agent spins out other agents, or asks the other agents to do something, waits for the output, for the results, and then does something else. So the only downside of this, not only downside, but the biggest downside of this kind of scheme is that, we have a single point of failure, and if we kind of have a deeper tree, then we have even more points of failure, because if one of the agents collapses here, then the entire chain collapses, so we wasted a lot of resources. And if the kind of head agent collapses, then we wasted the entire computation. And the last pattern that we've been presented with is critic reviewer scheme. It's once again it kind of resembles the sequential handoff. It's kind of, I'd say, hard-coded sequential handoff. So in sequential handoff, we have arbitrary steps. In critic reviewer scheme, we have the creator agent that produces some output, and we have an LLM as a judge, a reviewer, a critic that either provides the score that we can use later, or it can provide the actual feedback to the creator. And I think probably the biggest challenge here is once again to make them uncorrelated. So we should use either vastly different prompts, or probably better use different LLMs with different prompts to have uncorrelated content that we produce and the review of that content. Because I think that it's been shown that the same LLMs have a tendency to accept their own output more with a higher degree of certainty than output from other LLMs. So it might be a good idea to use different LLMs here. And the idea is that we have, once again, we have creator, we have reviewer that reviews the data. The reviewer can actually pass the initial draft and the critical assumptions to the revisor, like the final agent. And I think that this scheme, what it got wrong, that probably the revisor agent would decide if we need to go back to the creator or if we're fine and we can ignore the critic instructions, and then we produce the final output. And really, this is it. So far, it's been reading fairly light. I mean, probably what we're currently missing is observation, like observation of what real world systems use. Um, and I think we can maybe dive deeper into what real world systems use on Monday if Anya wants to do that. Um, but I don't think that we have very well established practice of like this works and this doesn't yet because LLMs change so fast. So what didn't work yesterday, for instance, maybe this pattern didn't work yesterday because we didn't have enough certainty in each one of the steps. It might work tomorrow, so I wouldn't really try to um, set any hard requirements or expectations now as to what works and what never works, because what works tomorrow, what doesn't work today might just as well work tomorrow. And this is it from me for today. Do we have any questions?
I have a question. I'm curious, what will be the difference between two models if the first one, for example, was fine-tuned with these examples how to properly call tools, and another one is didn't have that in the training data. Maybe if the model is big enough, smart enough, will it be able just to, figure out how to call these remote functions by itself without any fine-tuning?
Maybe. What I found is that models already show some glimpses of understanding of how to use these tools during like just from pre-training, because in pre-training they already have this XML like signatures. So probably my gut tells me that if we do few shot prompting when we show the model a few examples on how to do that, so that might not be necessary. And I also saw like here when I investigated how the models are trained to use tools, I think that there were experiments to even start adding the tool calling data, data annotated with tool calls, even in the pre-training mix. So yeah, that might work.
Interesting. Thank you.
Anything else?
I do have a question, but it's not like entirely related to the book. I decided I want to build an agent in terms of like agentic AI, and I spent 2 days investigating LangGraph, and I hate it already. So I'm wondering if anybody, I don't know, Andre, including you, have you used anything else? So I'm looking now. I haven't tried it, but I'm looking now at Crew AI and Agno, whatever that means. But I haven't touched it. I will. Like when you build agents, like what did you use, guys and ladies, over that?
I've been to one hack, and there we used Agno as a framework, and it was pretty much
Uh-huh.
okay to well, easy to assemble that. So during, well, it was 2 days hack and plenty of people, but I
Hmm.
think we lost a lot of time on just communication, as like we behaved as agents in the groups, and like trying to understand what the other group wants to achieve. So
Okay.
there was a group with like workers, like individual contributors. We tried to build like final
Hmm.
agents. Then there was a group like thinking on the manager type of the agent, and uh, I I wouldn't say that, well, we achieved some baseline solution in the end of
Hmm.
the day. And so I stopped there. But at least the experience with framework was nice, and they have a lot of examples for, okay, if you want to try certain type of agents, so it's like certain type of exercise, you have just setup of how to use it. So I think,
Okay,
yeah.
perfect. Thank you. Yeah, I will then explore it first.
I don't have the comparison with any other systems, so like I
Okay.
cannot tell you if that's the best choice of everything.
Yeah, I gave up on long chain. Like, this is not me. Andrei, what did you use? Like, because you
Nothing.
mentioned it.
Nothing really.
Okay, good.
Didn't have time to properly play with agents yet.
I had a good experience with the Llama index.
Uh-huh.
It is very modular, so they store all the different functionality related to different LM providers in a separate Python packages. So you just pull in different packages, and if you need them. And yeah, comparing to the LangChain, I'm not sure why this framework is so popular, because everyone who tried it, everyone hates it. It's so complicated. So yeah, you can try Llama Index. It's fine. I
Okay.
haven't tried personally Google's ADK, which is being used in the book in examples, but my
Mm-hmm.
colleagues used that and they liked it, so
Okay.
kind of recommended these two, Llama Index and Google's ADK.
Perfect. Thank you so much. Thanks.
Maybe one more note from my side. So if so I want to automate some of my routines, and I know that some of them are definitely rule-based with some LLM or agentic functionality inside. And I tried to play a little bit with N8N, and my experience is that it's so I would use it. I ended up after my several days of exercises with, okay, export me the JSON of the schema that I have. Then I go to any like Copilot or whatever. I ask it to make it whatever I wanted, because it's harder for me now to connect the nodes rather than say, no, I want, like, instead of separate emails processing, I want batch processing, and it should be batch on level of prompt or something. So, and then it's okay, I am updating it and I'm importing it back to N8N UI, but you can also host it locally. So yeah, for deterministic
Okay.
flows with some calls to some AI nodes as well. I think I would continue with that.
And I then.
Yeah.
Okay. Perfect. Thank you so much. It was very useful. Thanks.
At least that's what I'm going to explore soon.
All right. I guess if we don't have any other questions or topic to discuss, then see you tomorrow. Well, not tomorrow. Monday. Monday for memory management, learning and adaptation, and MCP. And maybe some more, like let's discuss it offline, Anya. Maybe we can.
Yeah.
Maybe we want to speed it up even further because it reads very lightly so far.
Yeah. I wanted, I don't know if it's like you can stop recording
Yeah,
because it
we
will be.
stopped the